Hi, this is Mr. Miller, and in this video we're going to talk about the end behavior of rational functions. Okay, this is our first example. We're going to determine the end behavior of this rational function here, f of x. We have the graph here, and we can kind of see the answer from the graph. As x approaches negative infinity, the graph is approaching 0 on this side and 0 on that side. So it has a horizontal asymptote of y equals 0. But we want to be able to see this from the formula. So in class, we've talked about how only the leading terms matter for the end behavior. When x is large or positive or large and negative, only those terms matter. These terms will be small in comparison. So for large x, our function is approximately equal to 3x over x squared. And if I cancel one of the x's, we get 3 over x. Now, as x gets large, the numerator is 3, but the denominator is getting huge, which means the fraction is going to 0. So constant numerator, large denominator means the fraction is small. So as x goes to negative infinity, this quantity is going to 0, and as x goes to positive infinity, it's going to 0 also. And we have the y, or the horizontal asymptote, y equals 0. This is what we said in the beginning. All right, here goes our second example. In this function, we can see that from the graph, it looks like it's approaching 5 here. This is 5 on the y-axis, and it looks like it has a horizontal asymptote there. Okay, well, let's see it from the equation. So for large x, these terms really don't matter, and this is approximately equal to 5x squared over x squared. Well, both have two factors of x that we can cancel, and this is pretty much just equal to 5. So we see as x goes to negative infinity, the function is approaching 5. And as x goes to positive infinity, the function is approaching 5. That fact. So, as we saw from the graph, the horizontal asymptote is y equals 5. Okay, let's take a look at this one. This one we can tell from the graph something different is happening. So if I do the same thing, if I cross out the lower order terms and keep the leading terms, we see this is approximately equal to 2x squared over x, which is equal to 2x. Oh, that's different. That's not a constant. And we see as x goes to negative infinity, if we put in large negative values, this goes to negative infinity. We can see that here in the graph, it's going down to the left. That's the end behavior in that direction. As x goes to positive infinity, well, this number is going to infinity also. We can kind of see that from our study of polynomial functions. This has a positive leading coefficient and an odd power. We know from our reference sheet that it's negative infinity on the left, positive infinity on the right, and that's what we see in the graph. So this function actually does not have a horizontal asymptote. It has a slant asymptote. So it's a line, but it's not a horizontal line. Okay, so we could do some more to come up with an equation for that line, but we're going to leave it at that. If it's a slant or curved asymptote, we're just going to leave it and say it's one of those cases. All right, fourth example here. So this function, kind of interesting looking function. But let's do the same thing. Let's cross off the terms that aren't going to matter much. And this is approximately equal to x cubed over 4x. And if I divide an x, we get x squared over 4. That's actually an equation for a parabola. That's a quadratic function. And that's why, except in the middle, on the ends, this function looks like a parabola. See, we can have a parabola here, it has this asymptote in the middle, and then it continues being a parabola again. For large x, this is very much like this function. The leading coefficient, 1/4, is positive, the degree is even, and on both sides, this goes to positive infinity. So we don't have a horizontal asymptote. We don't have a slant asymptote. This time we have a curved asymptote. It approaches this parabola, this curve, as x goes to infinity or negative infinity. Okay, those are the kind of things that can happen. Those are what we need to be able to identify. So here we got a little mixed practice. I'm going to cross off the terms that aren't going to matter much. And this is 3x squared over x squared, which is equal to 3. So as x goes to negative infinity, 3. As x goes to positive infinity, 3. And the horizontal asymptote, y equals 3. I know it has a horizontal asymptote because there's no x here in the numerator or the denominator. We just have a constant. Okay, let's look at this one. Cross these guys out and that guy. We have x cubed over 3x squared. And if I cancel the x's, this is x over 3. This is a linear function. Positive leading coefficient, odd power. That means on the left is going to negative infinity. On the right is going to positive infinity. And it is a slant asymptote. Okay. On this one, 2 more. So when we cancel those terms, we're left with the function is about 3x over x squared, which is negative 3 over x. Okay, as x gets large, the denominator gets big, and this goes to 0. So on the left, it's approaching 0. On the right, it's approaching 0, which means the horizontal asymptote is y equals 0. All right, last example. Let's cancel these out. And this is equal to 2x squared over x squared. So that's equal to just 2. Okay, as x goes to negative infinity and positive infinity, our function's approaching 2, which means the horizontal asymptote is 2. Okay, before we wrap this up, I'd like to share a little table with you. Here's a table that explains how we get the different asymptotes. So if the degree of the numerator is less than the degree of the denominator, the asymptote will always be y equals 0. An example of this would be like 2 over x plus 1. The degree of the numerator is 0, the degree of the denominator is 1. So whenever the denominator wins, the asymptote is 0. If they have equal degrees, like the degree of the numerator is 1 and the degree of the denominator is 1, then it's just the ratio of the leading coefficients. So in this case, it would be y equals 3. We saw this a lot when we were doing simple rational functions. If the degree of the numerator is 1 larger than the denominator, like this one, this is quadratic and this is linear, then we're going to have a slant asymptote. Because when we do the canceling, like 3x squared over x, we're going to get an x in the numerator, and that means it's a linear function. We get an x to the first. If the numerator is more than 2, greater than the denominator, then we get a curved asymptote. That's like this one, x cubed plus 7 over x plus 1. When we do this, we're going to get x cubed over x, which is equal to x squared, which is a curve, all right, asymptote. So we'll get used to this table, and after you practice this, you'll get used to what this means. All right, good luck.